Good morning, dear children. In this video, we will be learning about energy transformations, law of conservation of energy, power, its formula and SI units, and also we will learn about commercial unit of energy. So let us start. Our first topic is transformation of energy. The conversion of energy from one form into another form is called transformation of energy. You know that energy exists in many forms. We have sound energy, we have light energy, solar energy, electrical energy, heat energy. So, one form of energy can be transformed into another form. But whenever energy is converted from one form to another, the total energy always remains same. So let us understand some examples where transformation of energy is done. Our first example is the conversion of electrical energy to mechanical energy. A fan, a mixer grinder, a washing machine, etc. They convert electrical energy to mechanical energy. Then second, we have chemical to electrical energy. For example, an electric cell, it converts chemical energy to electrical energy. We can have another example where light energy is converted to electric energy. For example, a solar cell, it converts light energy of sun to electrical energy. In the same way, a bulb or a tube light converts electrical energy to light energy. So transformation of energy is possible, but whenever energy is converted from one form to another, the total energy always remains the same. And this leads us to law of conservation of energy. So let us understand its statement, the statement of the law. The law of conservation of energy states that energy can only be converted from one form to another. It can neither be created nor destroyed. It means the total energy before and after the transformation remains the same. Now let us understand it with the help of one example. Let an object be allowed to fall freely from a height. You know that when the object is present at certain height, then it has only potential energy. At the start of the fall, the potential energy is more. But as it falls down, the potential energy starts decreasing and kinetic energy starts increasing because now the object has come into motion. The potential energy decreases and kinetic energy increases. And when that object is about to reach the ground, then kinetic energy is the largest because there the velocity will be largest, and the formula of kinetic energy is half mv square. So kinetic energy will be largest, but potential energy will be least because now the object is about to touch the ground. But the sum of potential energy and kinetic energy is same at all the points during this fall. At all points, the total energy, that is potential plus kinetic energy, remains constant, and the sum of potential and kinetic energy, it is known as total mechanical energy. Our next topic is power. So what is the definition of power? Power is the rate of doing work. If an object does work at a faster rate, then it is said to be powerful. If W is work done and T is time, then power is equal to work done upon time taken, or power is equal to W upon T. Now let us talk about SI units of power. The unit of power is watt. The symbol for watt is capital W. Now what will be the definition of 1 watt? So 1 watt is the power of an agent which does work at a rate of 1 joule per second. Therefore 1 watt can be written as 1 joule per second. The bigger unit of power is kilowatt. In 1 kilowatt, it is equal to 1000 watt, or we can say it is equal to 1000 joule per second, because 1 watt is joule per second. Therefore 1000 watt, it is equal to 1000 joule per second. Next we have commercial unit of energy. About SI unit of energy, you know already, it is joule. But commercial unit of energy is kilowatt hour, and the symbol is kWh. So what is 1 kWh? 1 kilowatt hour is the energy used in 1 hour at the rate of 1 kilowatt. It means if 1 kilowatt of power is consumed in 1 hour, then we will say that energy consumed, it is equal to 1 kilowatt hour. Now let us understand the relation between commercial unit of energy and SI unit of energy. It means we will correlate kWh and joule. So 1 kilowatt hour, it is equal to 1 kilowatt into 1 hour, and 1 kilowatt, it is equal to 1000 watt. So in place of 1 kilowatt, it is written here 1000 watt multiplied with 1 hour, and again this 1 hour, it is equal to 3600 seconds. So you multiply 1000 with 3600, then you are getting, it is 36 with these 5 zeros, so many joules. So it is 36 into 10 raised to power 5 joules. And as you know, we are to write it in the scientific form. Therefore, after first digit, we have to put decimal. So it becomes 3.6 into 10 raised to power 6 joules. So it means that 1 kilowatt hour, it is equal to so many joules. It is 3.6 into 10 raised to power 6 joules. Now the electrical energy used in homes and industries, it is always expressed in kilowatt hour, and the electrical energy used during a month, it is expressed in units. So it means 1 unit, it is equal to 1 kilowatt hour. So in common language, 1 kilowatt hour, it is also known as 1 unit. And as you know, during after 2 months we get electric bill. So whenever you get your electric bill, then you have to check the previous reading of meter and new reading of meter. So if you subtract these two values, previous reading of meter will be less and new reading of meter will be more. When you subtract them, then whatever is the difference, it is expressed in units there. We always say that within 2 months we have consumed 900 units of electricity, or we have consumed 1000 units of electricity, and as per the rate of 1 unit, as per government rate of 1 unit, we have to pay electric bill. That's all in this video. Good luck.